Hello all, I want to welcome you to today's class. Today we will be starting our module 5. The module 5 will be talking about balancing chemical equations in the first lecture. Before we do that, as usual, I have a beautiful quote for you here. It says, "Success is not final, failure is not fatal. It is the courage to continue that counts." This quote was by Winston Churchill, one of the greatest leaders in the world, as it were, and former Prime Minister of the Great Britain. I will not talk much about this, but just what I want you to know, take away is this, is that no matter the current situation, no matter the current standing, what matters is your ability to be consistent. The courage to be consistent is what matters. And at the end of the day, the end will justify the means. Let's take it off from here. Today, we intend to address three things in particular. We'll identify the reactants and products in a chemical reactions, in a written chemical equation rather. We'll balance written chemical equations, and then we convert word equations that are written in word equations to balanced equations, and vice versa. And we can also convert from word equations. We can convert from written equations to word equations, as the case may be. So these are the things the questions you expected to answer by the time you finish listening to this class. Chemical equations. What are chemical equations? My best definition is to define chemical equations as shorthand, where we can represent a chemical reaction. Of course, a chemical reaction is a chemical change. So if we can represent that on paper in a short way, we'll do that as chemical equations. And that will give us dividing chemical equations into two parts, into the reactant and the product. Of course, the reactants are those things that are about to get into a chemical reaction. The product are the results of that chemical reaction. A very good example is the formation of water or steam. Here you look at that. To the left is where I have my reactant, and to the right is how my product, those things that are forming from the reactant. Of course, if you look at this equation very well, at the end of each of these molecules or substances reacting, you see a parenthesis, and inside a parenthesis you see a letters. Now, we usually represent this as the physical state of matter. Now, of course, the gases are represented as G. If they're liquid, represent the pure liquid. You represent them as L. Pure solid, represent them as S. And if those substances are dissolved in water, you represent them as AQ, which simply means aqueous. AQ simply means aqueous. That means it is dissolved in water. That's exactly what I meant. All right. So part of those I said earlier, I've already said this, that reactants are substances that undergo, of course, there are substances that undergo the chemical change. Every reaction is a representation of a chemical change. And then the product are those things that are formed as a result of that chemical change. Now, when you have two reactants or product in a chemical reaction, they are usually separated by a plus sign. A plus sign means two things are coming into intimacy of a chemical reaction. And then when you have the product side and the reactant side are separated by a comma. If we go back to that equation, we found out that to the right is the product, to the left is the reactant, and they're separated by an arrow. That is the function of this arrow here, to separate the product from the reactant. Now, so we move on from there. Now, what about balancing of equation? Balancing of equation simply obeys the law of conservation of matter, or you can call it the law of conservation of mass. What it's simply saying is that, of course, matter can neither be created nor destroyed in a chemical reaction. What actually happens, like we did in the earlier chapter, it is to see that it is changes from one form to another, and the same thing is happening here. Now, remember, in balancing equations, what we are doing is to balance the number of atoms of each element present. Of course, this element represents the simplest form of substances we talk about. Now, the number of atoms of each element in both the reactant side and the product side must equal. So there's no way they can be different, and that is actually what we're going to be doing. So And how do we balance that? What we simply do is to add coefficient to the right of each element or substance. To use that idea of the trial and error, of course, we use the trial and error at test student. The best method to use is the trial and error method to balance equation. To make sure that as we add this coefficient in front of each of these elements, that at the end of the day, the number of this element in both sides of the reaction balance. Then let's take an example and do this in this case. In this case now, if you look at this equation, we can first of all, usually at test student, you can start simple by counting the number of atoms on both sides of the equation. Usually I advise students to do this, that it doesn't matter. If I draw a table here, and now the table to the column to the right represents the product, to the left represents the reactant. If I say, okay, let me count the number of these things that I have here. So my H here, I have 2 atoms of hydrogen on this side, and oxygen, I have also 2 atoms of hydrogen. If I go to this is to the left. If I go to the right, I have 2 atoms of hydrogen to the right, and I have only 1 atom of oxygen to the right. And then to balance this equation, what I'm simply going to do is to add coefficients in each of these spaces I created to make sure that they're balanced. What am I going to do? Hydrogen is 2, hydrogen is balanced. I don't have a problem with hydrogen. But I look at this. Oxygen is 2 to the left. What I will think is algebraically, I'm going to add 2 to this front. And adding 2 here simply means I'm multiplying this by 2. If you multiply 1 oxygen times 2, that gives me 2. What that simply means is that I have actually added 2 here. This is 2 oxygen. But I've messed up my hydrogen here. What it means is I've also multiplied hydrogen by 2. So I'm going to get 4 here. And to correct my hydrogen at this point, I have to multiply this one again by 2. I'm multiplying 2 is adding 2 here, and this gives me 4. Now this equation is balanced. If you look at this, there is 2 times 2, 4 hydrogen here. There's 4 hydrogen here, 2 oxygen here. And at the end of the day, because there was nothing added here, you'll always add your coefficient as 1. You don't have to add it, but most times the test students at this level, you can always add it. It helps you to know your standing. It doesn't take away anything to add just 1. So this is exactly how we use the trial and error method to balance chemical equation. And we're going to do a lot of problems as we move. Now, I have some important useful tips. You need to take note. These useful tips will help you to balance equation very fast and accurately. The first thing is that we balance equation using the trial and error method. That's the only most convenient way. There are other methods that involves using linear equations, algebra, or matrices. Those are much more complex to what we'll be doing in chemistry and at the level of this class. Secondly, if you have metals, try to balance the metals first. Secondly, you now balance other non-metals except hydrogen and oxygen. You balance every other guy except these guys, and then balance the hydrogen, and then oxygen usually comes last. And finally, now in some reactions, you find that you find the polyatomic ions, which of course, remember before now we had said that polyatomic ions represent single entities. That is the way they exist. We treat them as a single entity and balance them the way they are, provided they do not change on both sides of the equation. At times, they do change on both sides of the equation. In that case, you have to balance the individual elements in that polyatomic compound. And finally, you do not touch the subscript. Touching the subscript changes the identity. If you touch the subscript, you change the identity. It changes the identity of substances. You change the identity of those substances or elements or the way they exist. So you do not touch them for any reasons. Just leave them the way they are. So these are the useful tips, and the next thing we're going to do is to take it into action and begin to do our balancing of equation immediately without wasting time. The first question here gave us both in words and equation. It says methane combines with oxygen when it bonds to form carbon dioxide and steam. Steam is the gaseous form of water. According to the equation below, it's a balanced equation. Again, I tell student, we're going to start by drawing a table. I like using my red. I'm going to go back to it. So I'm going to go back to the red. Let's start. Now, so what I'm going to do, I'm going to count the number of atoms on both sides of the equation. So let's count the number of atoms. The first one I have here is carbon. how many carbon do I have? I have 1 carbon here. And then hydrogen, how many hydrogen do we have here? 4 hydrogens. Then oxygen, how many oxygen do we have here? We have 2 oxygens. Then we go to the right side. The right side also have two substances there. Carbon here. Usually try to maintain the same horizontal line for each type of element. So here carbon also has 1 here on that side. Then hydrogen, what's our hydrogen? Here hydrogen has only 2. So we're going to say H equal to 2. And then oxygen here has, look at. Now, if you come in contact with this kind of problem, I tell students, the best thing to do is to treat this as an algebraic equation. Now, some authors or some other people will want you to say, okay, 0, you have 2 plus 1 is 3. No, I advise students, make this thing looks like an algebraic equation. Look at what you do. Here now we have oxygen. There are more than one stuff here. So on this side, there is 2. On this side, there is 1. So I'll say 2 plus 1. I know it's 3. So it is better to do it this way. We're going to see why this helps a lot. We're going to see why this is more important and convenient. And then we move and start balancing our equation. What's the first thing we do? We balance carbon. Remember, in this case now, we will balance carbon. That's the sequence. Like if you look at my tips again, I'm going to balance carbon first. After carbon, I'm going to balance my hydrogen, and oxygen comes last. So if my carbon 1, 1 is balanced. Now, when you have 1, 1 in your equation, do not hurry to add the 1 immediately, because something might be messed up along the line. So I'm not going to add it, but it's balanced. We don't have problem with that. I go to hydrogen. 4 hydrogens here. I have 4 hydrogens here. I go this way. I have 2 hydrogens. How do I balance it all? What I have to do is to multiply this out by 2. If I multiply this by 2, I'm going to have 4 hydrogens. What it means is I'm going to add 2 in front of hydrogen. 2 times 2 is 4. But I have messed up my oxygen. You see that? We're trying to balance my hydrogen. My oxygen is messed up. What am I going to do? I'm going to fix my mess up immediately. So now what it means is that the oxygen that is on this side has been multiplied by 2. So I'm going to say bracket 2. So what that simply means is that 2 plus 2, my oxygen is now 4. Remember, my oxygen is 2 here. So what do I do? Since it's 4 here, I'm going to multiply it by 2. I'm multiplying by 2 here. The only place it is here is to add 2 here. And at the end of the day, if you multiply this 2 by 2, it gives me 4. Here gives me 4. Here gives me 4. And my equation is all balanced. Now, I will always advise you that if you can always pause this video, then go try this question and come back and check it for comprehension. Now, this one is a typical case of we have a word question, a word equation. We're not going to write it, and then we balance it. These are the 2 things we're going to do. We're going to write it. It says sulfur trioxide is an air pollutant responsible for acid rain. It is produced when sulfur dioxide gas react with oxygen. So look at the 3 things we need to call. So this is, remember the reactant comes in first. So I'm going to put it first. So first of all, it starts from sulfur dioxide. I'm going to put SO2. Of course, I don't know what it is. I'm going to put dash here to balance it. SO2 plus. Now, sulfur dioxide is a gas. So I'm going to put gas plus. And then what next? The next thing I'm going to do is to add my oxygen. So it's going to be oxygen. Again, I don't know what is here, so I'm going to put gas, giving me sulfur trioxide, which is SO3. Again, it is a gas. I'm going to put this. That is a chemical reaction. From the name, remember we've done nomenclature, and that is the usefulness of this. Although in this case, in trying to test you, I'm not testing you for nomenclature. So I'm always going to write the formulas if I'm going to give you this exam. But assuming that is not done, you came in contact with a place where it was not written, you should be able to comfortably do this at this point. Now I draw my table to balance the equation as usual and count my atoms. Towards the right, I have sulfur, and I only have 1 sulfur here. And oxygen here, I have, okay, now again we come in that. Oxygen here is what? 2 plus 2. You see that I told you? 2 plus, we have oxygen 2 plus 2. It's important always to do this. 2 oxygen here, 2 oxygen here. And then we go to the other side. Again, sulfur here is 1. Then oxygen here is what, how many? Just 3. And then we balance the equation. I'm going to use different color now in this case to help make it different. My sulfur is balanced. So I go to oxygen. If you look at this, there are 4 oxygen here to the left and 3 oxygen to the right. What am I going to do? You think, okay, how best do you fit in this oxygen to make it balanced? How best do you think you fit into oxygen to make it balanced? Now, I want to do something here. What I'm going to do is, this is 3. If I multiply this by 3, it's going to give me 6. And what it means, if I multiply this one by 2, I'm going to have 4 here plus this. So I'm going to do that. I'm going to just add 2 at this point. If I add 2 here, I've multiplied my oxygen by 2. This gives me 6. However, I've messed up my what? Sulfur. I'm going to multiply my sulfur by what? By 2. Again, it's going to give me 2 sulfur. Now, because I've messed up my sulfur to the left, I have to fix my sulfur to the right. I've messed up my sulfur to the right. I have to fix my sulfur to the left. So what am I going to do? I'm going to go back here and multiply by 2. I'm going to add 2 here. That's going to give me 2. My sulfur is fixed. However, remember my oxygen ab initio here was messed up at 6. If I go back here now, this sulfur, in fixing this sulfur, my oxygen here becomes 2 times 2, 4. That means I have to multiply this by 2. 2 times 2, 4. And if I add it 2, that gives me 6. If you look at it now, so there is 6 oxygen, 6 oxygen, 2 sulfur. Since I didn't add anything here, I can drop 1 at this point. Now the equation is balanced. This is the balanced equation for this reaction. The next problem, it says balance the equation. This is gallium sulfide reacts with hydrogen. Again, remember the tips. There's a metal here, so I'm going to balance my metal first before the hydrogen. That's the thing. So I'm going to balance the metal first. That's the first thing I do. If I'm going to do that, I'm going to draw my tables again. Remember, draw my table again. So I'm going to write out, count my atoms. If I'm counting my atoms, do that with red. So gallium here is 2, sulfur here is 3, hydrogen here is 2. I go this way again. Gallium here is 1, then sulfur here is 1, and hydrogen here is 2. Now I'm going to balance my gallium first. Gallium is 2 here. Of course, I'm going to use green to do that. Gallium is 2 here. Gallium is 1 here. So what do? I multiply this by 2. Add 2 here. My gallium is 2. Gallium is balanced. I don't have a problem with gallium anymore. Now, my sulfur is 3. I have 3 sulfur. So, it's 3 at this point. To the right is not. So what am I doing? I'm going to multiply this sulfur times 3 to give me 3. What it means, I'm going to add 3 here. If I add 3 here, my sulfur is balanced. However, in balancing my sulfur, I've messed up my hydrogen. So 3 times 2 means my hydrogen is multiplied by this to give me 6. How do I fix it? I go back this way. Hydrogen only occurs on one side, so it's easy. I'm going to fix this by multiplying this by 3, and that gives me 6. If you look at it, gallium is 2, gallium is 2, sulfur is 3, sulfur is 3, hydrogen is 6, hydrogen is 6. My equation is balanced. I'm not going to drop 1 to this point. I have a balanced equation. Yes, you can pause this video at this point. Try a few problems and then always come back. Now, the next 2 problems, we will use the fraction method in balancing this problem. In problem 4 and 5, we're going to be using a fraction to balance it. We're going to be using fraction. It is not necessarily a fraction, because at the end of the day, we need to remove the fraction by multiplying all through. But it makes it faster. It just helps you make it faster. And most of this kind of equation looks like combustion of organic compound. That's why we usually see this kind of equation. Combustion of organic compound. So usually in this kind of equation, carbon will be burnt. Then it gives you, carbon will be burnt. It will always give you carbon dioxide and water. So let's see how this problem is done. Now, you can also use table to balance this comfortably, although it might take a little bit longer. But I want to show you the easiest and shortcut to do this kind of problem when we encounter a hydrocarbon where its combustion. This is a combustion reaction to give you carbon dioxide and oxygen. So the form of this reaction actually is something like this. CXHY plus O2 gives you CO2 plus H2O. This is actually what this kind of reaction gives you, no matter what. Now, the first thing I'm going to do, like as usual, I'm going to balance my carbon. I have 4 carbon here. So to balance my carbon, I'm going to add 4. Now, okay, I'm going to start with my red and finish it with my... I'm going to start with my red and finish it with green. So this 4, I'm going to add 4 here. Because I have to clean out something as I do this. This is 4. So my carbon is 4, now my carbon is 4. Now, remember the rule. You balance everything before hydrogen and oxygen. So now I balance my carbon. So I'm going to balance hydrogen before oxygen. So I want to balance my hydrogen. There's 10 hydrogen here. Now, if you look at this side, there is 2. And I can make it balance by adding what? 5. If I add 5 here, I'm still balancing it. It's fine. Okay. This is now 5 times 2, 10. So what it means is that my carbon is balanced. 4 carbon, hydrogen 10 carbon on both sides. Now it remains my oxygen. Let me count the total number of oxygen. Here I have 2 oxygen. This side I have 4 times 2, 8. 8 plus 5 oxygen gives me 13 oxygen. Now, if you put 13 here, it's going to be too high. And you're going to start making something up again. Because there is 2 as a subscript here. Do you know what to do in this kind of problem? If it is an even number, if I had 12 over 2, it will balance this equation. But it's not even. So what are you going to do? I'm going to say 13 divided by 2. If you say 13 divided by 2, it's going to balance this equation. But equations do not accept fractions. It has to be a whole number. What do? We'll multiply everything by. So we're going to multiply across by 2 to make everything whole number. So let's do that. So now I'm going to go to my red. So I'm going to go to my red. So if I'm going to multiply everything by 2 to remove these 2, so what would that be? So if you multiply this by 2, this is going to give me 2. If you multiply this thing by 2, it's going to cancel out. Remember, okay, let's see. If you have 13 divided by 2 times 2 over 1, it will cancel itself. So what am I going to have here? What I'm going to have here will not be 13. So I'm going to cancel what I have here. Okay, let me take a small eraser and take it over. No, it's the lighter one. So now I'm going to have 13 here. Go back to my pen. So I'm going to have 13. And now multiply this by 2. What does it give you? Multiply this by 2 gives you 8. And then multiply this by 2 gives you 10. And now when you check it, everything, let's check it now. There is 2 times 4, 8 carbons, 8 carbons here, 8 times 1, because carbon is just one side. 2 times 10, 20 hydrogen, 10 times 2, 20 hydrogen. Oxygen is 13 times 2, 26 oxygens. Let's see. 8 times 2 here is 16. 16 oxygen plus 10 oxygen here, 26, and the equation is balanced. So you can pause this video now and then try the next problem. When you look at it, then after that you can come back, because the next problem will be the same way. Now this equation actually is a photosynthetic reaction. This equation represents photosynthesis. This is an equation for photosynthesis. Photosynthesis, remember, is when carbon dioxide combines with oxygen to make glucose and water. And then from here, the glucose can now be stored into starch and other forms of carbohydrate storage, of course. Now, so it is almost something we did last time, but the difference is that now the equation was like kind of a ton, but a little bit different, because now this is not a hydrocarbon. Now this also contains an oxygen, so this is carbohydrate. Now this is going to still work just like the last one. Let's try it and see what happens here. Again, let's start on both sides. You see here, carbon is 6, carbon is 1 here. To make it equal, I'm going to put 6 carbon here. If I put 6 carbon here, Now my carbon is balanced. I go to hydrogen. Hydrogen is 12 here. It doesn't occur any other place. 12. How many do I have here? It's 2. So what am I going to do? I'm going to add 6 here. 6 times 2 is 12. This is 12. Now it's balanced. Now I go to my oxygen. Remember, oxygen is the last. Let's count. There is 6 oxygen here. 6. Okay, let's start from here. 6 times 2 is 12. 12 plus 6, 18 oxygen. So there is 18 oxygen here. If we go to this side, we have 2 oxygen only on this side and 6 on this side. The one that usually gives a problem is the one staying alone. So we can easily balance this. What am I going to do? Because I know I have 6 here. I'm going to minus this 6. So if I do 18 minus 6, okay, not to make this thing confusing, let me just do 18 minus 6. So if I do 18 minus 6, I'm going to be left with 12 oxygen atom. So what it means, I don't have to do anything from here. I'm going to now balance the remaining from here. So what, there is 2 again. So what do I do again? I'm going to say 12 divided by 2. Unfortunately enough, 12 divided by 2 is not an odd number. 12 is an even number. So 12 divided will be 6. So I'm going to go back. I'm going to take this away. And then I'm going to add 6 to this. So now the equation is balanced. Since I didn't add anywhere here, I'm going to put 1 here. This is how you balance the reaction of photosynthesis. We go to the next problem. Now, this is another level of problem. In this type of problem, it involves, you look at it, this is a typical precipitation reaction. A precipitation reaction involves the formation of solid as part of the product. So you see there's a solid here, this is a precipitate. Now, but that is not just what happened here. Now, you see, there are polyatomic ions here represented. So what are we going to do? We're going to treat them as single entities. So again, like I always did, we're going to use table to balance. So I'm going to draw my table here. And I'm going to draw a line. Now we count. Here, aluminum. I have 2 aluminums here. Now there is sulfur here. This sulfur, I'm treating it as one entity. This is sulfate ion. So I'm going to say sulfur. How many of them do I have here? So this parenthesis means I have 3. So I have SO4 2 minus is equal to 3. Remember, sulfate is SO4 2 minus. We did this earlier in nomenclature. We have 3 of it here. Now, what else do I have? Barium here. Look at barium. So I have barium. So this is Ba. Is only 1. And I have nitrate. Look at this. Nitrate is 2 because of this parenthesis. So I have NO3 minus equal to 2. So I've been able to account for all I have at this point. And now go to the right. Again, here aluminum is turning out to be only 1 here. And then my sulfate again, SO4 2 minus. There's no bracket here, so this guy is only 1. And then what else? Barium. Again, barium is just 1 here. And then what else do I have here? Nitrate. If you look at nitrate, nitrate is equal to how many? 3. I have 3 nitrate in that reaction. So oh, it asks us to write this in words. Okay, I'm going to find a space to write that. I've already taken a lot of my space. So what do? The next thing, we better begin to balance. Now, balance the metals first. Remember. So we have metals here. So I want to balance my aluminum first and see what happens. I have 2 aluminum here. I have 1 here. So what do? I'm going to multiply this by 2 to make it 2 aluminum. What it means, I'm going to add 2 here. So my aluminum is balanced. Now listen, when you are balancing an equation, if you mess up an entity, a polyatomic ion, an element, or whatever, treat it first before you come back to continue with the sequence you have. Remember what I told you, we're going to balance the metals first and then come back. That is okay. But in trying to balance this metal, I've messed up my nitrate. So I'm going to go fix my nitrate. If you look at this now, nitrate is 3 here. If you add it to this, 2 times 3 is 6. I'm going to go to my nitrate immediately and multiply by 2. And this gives me 6 on this side. But I have to fix it on this side. To fix my nitrate on this side, what do? Remember, this is 2 here. Nitrate is 2 here. To fix this, I have to multiply by what? 3. To make it 6. What it means is I have to add 3 here. If I add 3 here, my nitrate is okay. But I've messed up my barium. Look at my barium now. My barium becomes what? 3. What it means, I have to go back and fix my barium. If I go back to fix this barium, what will my barium be? Barium is 1 here, so I'm going to times it by 3 again. To make so what it means, I'm going to put 3 here. If I put 3 here, my barium is now 3. And again, I've messed up my sulfate. Here, my sulfate is, see, my sulfate is 3 here. Oh, and I go back there. My sulfate is 3. I don't have to do anything about that. That makes it cool. So I was thinking I messed up my sulfate, but you see, if you balance this equation, if the equation is correctly written and you're balancing it, you find out that as you try to mess up what you, so you try to correct what you messed up, it will lead you to a properly balanced equation. So let's count. 2 aluminum, 2 aluminum. Sulfate is 3, sulfate is 3. So remember, I didn't finish up. Now my sulfate is 3, I have to always show it on this side. Times 3 is equal to 3. So my sulfate is 3, my sulfate is 3. My barium here now is 3, my barium is 3, which is the one we have here. And now my nitrate is 3 times 2, 6. Here, 3 times 2, 6. The equation is balanced. This is how you balance this equation. Now, let's write the in word. I hope I have get space. So it will be aqueous, let's see, aqueous aluminum sulfate reacts with aqueous barium nitrate to form solid barium sulfate and aluminum, this aluminum nitrate. The knowledge of nomenclature will help you to figure out these names. Remember, we did this in the previous I would say in the previous 2 modules we addressed nomenclature of organic compound. All right, this is what it is at this point. So we'll get to the next problem. Balance the equation below again. This equation again. So you can pause this video at this point in time, try these problems, and then come back and see if you got it correctly. So let's balance the equation again. I'm going to draw my table. This time I'm going to draw it now and give myself some space down here, not to take all my space. Here I have lead. Let's count all the atoms. We have lead. Lead is only 1 to this side. And then I have nitrate followed. NO3 minus is just 2. And I have sodium. Sodium is 2. And what else do I have there? Sulfate. Sulfate is 1. Then again I go to this side. I have my lead. Lead gives me 1. Nitrate gives you 1 at this point. Then sodium is 1. And sulfate is 1. So let's start balancing. My lead, balance metals first. Metal, lead is balanced. So let me go to my sodium. My sodium is 2 here, is 1 here. So I'm going to times it by 2. Add 2 here is 2. Sodium is balanced here, but I've messed up my nitrate. My nitrate is now 2, right? So what do? So my nitrate is now 2. So I'm going to go fix my nitrate. If you go here, the nitrate is already fixed. It's 2, so I don't need to touch it. And then, so I have my lead fixed, I have my nitrate fixed, I have my sodium fixed. What about my sulfate? My sulfate is 1. Sulfate is 1. No need to fix it. The equation is balanced. So if you want to just help out, you can just add 1, 1 on all sides. And then your equation is balanced. The next one, still on polyatomic. Students struggle with this. That is why I included a lot of problems on this polyatomic ion side of equation, because students struggle with these polyatomic ions so greatly. Again, we'll do this one. Again, we'll start ion. Here, ion has 2. After ion, sulfate is 3. And then after sulfate, what is we have potassium. Potassium is 1. It's 1 potassium here. And then OH. OH is 1. Now, in doing this, you don't necessarily need to write. This is a scratch work. Whatever you're doing here is scratch work. You don't necessarily to write the identities of the ions or elements or the correct way you need to. It's just a scratch work. What is going to help you to count your atoms properly and balance it. I go to the right. Ion. Here, ion is just 1. That's what we have. Go to sulfate. Sulfate is 1. That's what I have here. And I go to potassium. Potassium gives me 2 here. And then I go to OH. Oh yeah, OH gives me equal to 3. That's what I have here. So let's start. Ion is 2 here. I want to balance my ion first. It's a metal. Add 2 here. Gives me 2. Now if you look at this, I've messed up my what? My OH. My OH is now 6. So what it means, I've made it 6. So I have to fix it first. If I go here, it is 1. I have to multiply this by 6 to make it 6. So I'm going to add 6 here. 6 OH. My OH is bound. But in doing that, I messed up my potassium. What do? I have to go and check my potassium here. My potassium here has been messed up. So I multiplied it by 6 to be 6. If I go this way, my potassium here is what? My potassium is 2. To make it 6, I have to multiply by 3 to make it 6. So I have to add 3 here. So if you look at this now, let's see. Ion is balanced. My sulfate is not yet balanced because even here I messed up my sulfate to be what? 3. So I multiply by 3 here to be 3. So I'm going to go back here and look at it. Oh, it's balanced because there's already 3 here. And then everything is okay. So you see that? So I have ion is 2, ion is 2. Sulfate is 3, sulfate is 3. Potassium is 6, potassium is 6. OH, hydroxide ion OH is 6 here. It is 6 here. The equation is balanced. So you can always add a 1 here to show that your equation is balanced. All right, the next problem. Now, this is another problem. In this one, we're going to be writing this from word to equation. It says when a powder mixture of aluminum metal and iron 3 oxide is heated, it reacts to form liquid iron metal and solid aluminum oxide. Write a balanced equation for the reaction. So the first thing I need to do is when a powder mixture of aluminum metal. So powder means it's a solid. So I'm going to have aluminum as solid, react, iron 3 oxide. Remember how to write this. Remember, iron 3 means it is Fe3 plus. Oxide is always 2 minus. If they swap their sign, it's going to give me, remember that? It's going to be Fe2, and then oxygen will take the 3. So this is going to be, I'm going to give space for balance. Fe2O3. This is the formula. So they're heated. This is usually the sign for heat. The triangle sign is written below or above the arrow. It doesn't matter. And then to form liquid iron. If that means this is a displacement reaction. Tell me what it means. Aluminum will come and kick out iron. So it forms iron on its own. So it becomes liquid plus and solid aluminum oxide. Again, aluminum is 3 plus. So if you exchange the charges again, aluminum is this, oxygen is 2 minus. It's going to still give you Al2O3. So this is going to give me Al2O3 solid. This is what the equation will look like. Of course, I'm going to put this because I'm going to balance the equation. Again, let's count the atoms we have on all sides of the equation. If I count the atoms, aluminum here is equal to 1. Iron here is equal to 2. And oxygen here is equal to 3. Here, aluminum here is equal to 2. Iron is equal to 1. And oxygen is equal to 3. So, in balancing this equation, we can start from anywhere. It doesn't matter. Here, first of all, aluminum is 2. Here is 1 here. So I'm going to just multiply this by 2, put 2. It's on its own, it's easy to balance. That is balanced. I go to iron and oxygen. Iron is 2 here. Iron is 2 here. You see that? So one is on its own, so it's easy to balance too. I'm going to multiply this by 2. If we put 2 here, that gives you 2. And then oxygen is 3 here. Oxygen is 3 here. The equation is balanced. So you can now add 1 here and 1 here, and the equation is balanced. Now, of course, the last but not the least of the problems we're going to be solving today in balancing of this equation is a balanced equation below. Here it says this is gold solid. It's reacting with oxygen to form gold 3 oxide. Again, we're going to draw our line as usual. We have a gold AU. Here is 1. Here oxygen is giving us 2. Then here we go. Again, gold is giving us 2. And oxygen here is giving us what? 3. Balance the metals first. Remember, oxygen always the last. So I'm going to balance my gold. There is 2 gold here. I'm going to multiply this by 2. That means add 2 here. My gold is now 2. Balanced. That's what it means. But my oxygen is 2 and 3 here. I want you to see what is going to happen now. So you find out this is an odd number. It will be difficult to balance this. And the best way I can think of balancing this is to do what? To balance this, you have to make this an even number. And don't, if I add 2 here now, 2 times 3 becomes 6. 3 times 2 is 6. My oxygen becomes 6 here. However, what happens to my gold? My gold is messed up now to become 4. What do? I'm going to take an error. Remember, this is trial and error. If I take this off, I'm going to make it what? Make it to be 4 on this side. What it means is now, what I did initially here is not going to work. Because I'm going to now multiply it by what? Is 1. Yes, I'm going to multiply it by 4. For it to be what? 4. So this is going to be 4. So I'm going to add 4 here. So my gold is now 4. So my gold is 4 here. My gold is 4 here. Remember, my oxygen is 6 here. To correct my oxygen 6 here, what it means is that I need to multiply this. If you multiply 2 by 3, it's going to give you 6. So I'm going to add 3 here. And now my equation is balanced correctly by counting those atoms. So it has been an interesting ride in this lecture. Thank you once again for listening. And if you do have any questions, do not forget the usual channels to get to me. If you have time, always stick into my office hours and talk to me. And once again, enjoy the rest of your day. See you in the next lecture. Thanks for listening. Bye.